This video explains how to check the ground insulation of an AC motor winding using the insulation resistance test, or IR test. The IR test is usually the first electrical test because it indicates if the motor winding can withstand further testing or the machine can return to service. This video shows how to select the mega ohm meter and the IR test voltage, how to connect the mega ohm meter to the winding and ground the leads, how to perform the IR test and for how long, how to safely discharge the winding, and how to correct the IR test result for the standard temperature of 40 C and determine if it is acceptable. As always, follow your organization's safety practices and procedures. To perform an IR test, you'll need a few tools and supplies: a mega ohm meter, a thermometer, a cell phone or a stopwatch, the ANSI ESA AR100 standard, ESA's AC 3-phase motor service order form, or the form used by your service center, and the IEEE 43 correction factor KT chart. For windings rated up to 1000 volts, the IR test can be performed with an analog or digital mega ohm meter rated for 500 to 1000 volts. Windings rated over 1000 volts may require a digital mega ohm meter rated at 1000 volts or greater. Instead of a mega ohm meter, you can use an analog DC high pot at the applicable voltage level to check the winding IR, whether it's a standalone unit or it could be built into a surge tester. The IR test applies voltage for 1 minute, which you can time with a cell phone or a stopwatch. Some mega ohm meters have a built-in timer for the IR test, but make sure it's set to 1 minute. Here, we're testing an AC squirrel cage motor with 3 leads. The procedure for a 9-lead motor would be the same as with a 6-lead, 2-speed, 1-winding motor, because all leads have continuity with each other. Although not covered here, motors with 6 or 12 leads that are a Y-delta configuration can also be tested with all leads connected together or have each phase tested separately. Isolate the machine from all power sources and attach the frame to ground or earth during the test. Follow the electrical safety procedures and discharge the winding after the test. Determine the machine's voltage rating from its nameplate. In this case, it's 460 volts. Referring to the ANSI ESA AR100 standard, we'll see that the IR test level for 460 volt motor is 500 volts. That means we'll need an analog or digital mega ohm meter rated for 500 to 1000 volts. Next, we'll use the mega ohm meter's 500 volt setting to check for continuity between all the motor leads. In this case, we have 3 leads. The mega ohm meter is working properly if it reads 0 mega ohms when you touch the mega ohm meter's leads together. Now check for continuity between all 3 motor leads: 1 to 2, 2 to 3, and 3 to 1. The mega ohm meter should read 0 in each case. This motor passes the continuity test, so we can proceed with the IR test. If a motor fails the continuity test, the winding is damaged and not suitable for IR testing. Allow the motor to cool to room temperature before performing the test. Depending on the motor size, it can take anywhere from 1 to 8 hours for a fully loaded motor to cool to room temperature. Note, if the motor is assembled, the winding temperature can't be measured unless it has embedded detectors. IR results will vary with temperature, so the next step is to observe the room temperature on a thermometer and record it on the datasheet. When it's time to evaluate the IR test result, we'll need to correct the temperatures to the standard 40 C that the AR100 standard uses. To prepare for the IR test, connect the negative lead of the mega ohm meter to all the winding leads. Now select the IR test voltage on the mega ohm meter. In this case, it's 500 volts. Connect the positive lead to the motor frame, also termed ground or earth, and apply the IR test voltage for 1 minute. Note the IR value on the mega ohm meter and record it on the datasheet. Disconnect both the mega ohm meter leads. For safety, always short the winding leads to ground for about 5 minutes, or at least 4 times as long as the test, to discharge any energy that is stored in them. To evaluate the IR test results, first correct it to the standard 40 degrees C in the ANSI ESA AR100 standard using the correction factor form in this graphic from IEEE 43. Note that all random windings have thermosetting insulation systems. Some digital instruments automatically correct the IR value to the standard temperature, such as 40 degrees C. If not, a good rule of thumb is that the measured IR value is at least 4 times the minimum IR level and the winding temperature is at least 20 degrees C. Now compare the temperature-corrected IR test results with the minimum values at 40 C for a 460-volt winding in the AR100 standard, which in this case is 5 megohms. That means that the winding ground insulation is acceptable if the temperature-corrected IR is at least 5 megohms. The IR test result is usually the first electrical test performed on an electric motor winding, and for good reason. By evaluating the condition of the ground insulation, it indicates if the winding can withstand further tests. This also makes it useful for determining if the machine is suitable to return to service.